So now we're looking within these three branches of machine learning, we're going to talk about supervised machine learning. So under supervised machine learning, there's classification, and then there is regression. So we want, for instance, a machine learning algorithm to identify where their cats are. So my sister, older sister, has a cute cat named Bandit, which I'll get to meet for the first time, hopefully tomorrow. And we want to see if a cat is visiting or a cat is near. Let's say we have a webcam. We want it to send a text message to me that the cat is there. And then maybe I can be alerted that, hey, oh, okay, somebody has a recommendation. Okay, let's check this out.
What? Is that a dog or dog, pig, dog, pig, dog, pig, pig, dog, loaf of bread, system error.
Oh, that's cute. That's like at making
Dog,
predictions.
pig, dog, pig, dog, pig, pig, dog, loaf of bread, system error.
Oh, thank you, Lachlan, for that. That's a cute suggestion as well for a video. That's cute. So yeah, guys, that is a very, very cute example. It seemed related. Yeah, okay, thank you for sharing that. That's awesome. So I appreciate all the content and ideas that you guys are sharing as well. So pretty much the idea is that, I want to predict if the cat is there or not, maybe the cat. So apparently if my mom mentioned that the cat is at home, the cat goes hiding and then they can't find the cat for days apparently. So they're coming to visit tomorrow, so I'm excited. So the idea is that like maybe I want an algorithm that predicts if the cat is there or recognizes if the cat's there and it's come out of hiding to come for food. So I need to give a lot of data to my algorithm. I have some webcam set up. Maybe it sees if the cat's there or not, for instance. And if the cat's there, I want it to send a message to me or to my family telling them, hey, the cat's there. Yeah, hiding for room. Yeah. So we give a lot of data on the cat and what the cat looks like, and then things that are not the cat and things that are the cat. So we give a lot of time spent training images of cats, images on people, not cats as well. And I label them. So this is the training time. Then the actual test is if the cat's there and it's predicting that that's a cat, then that is a correct prediction. It's recognizing cats correctly and not cats correctly. So it's the idea that we train a lot of people with masks and without masks, for instance. And then we spend a lot of time training. And then we have the actual test. This is the testing where, we give an image of you guys, some of you guys wearing masks and some of you guys not wearing masks. And then we see how it did. So I would go back and I would say, oh, this is wrong. Okay, this is correct, 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 correct. Okay, sorry, I did not recognize you wrong. Correct, correct, correct. Oh, correct, awesome. Correct, 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 correct. That's sort of like how it goes. I give lots of data to train this model of people with masks, a lot of data on people without masks. And then I'm noticing that, okay, it needs to maybe detect these backgrounds better. So maybe I need to give more data. So that's like the training process. So think of it like as, as Brianna was sort of mentioning that, you can imagine having the SATs or something, or I think it was Alyssa Ann, one of you guys was mentioning the SATs and trading and spending all this time training for the SATs. Along the way, if you make some mistakes, imagine if you're taking practice tests or you're taking them with the teacher or something, then if you make mistakes, it's like, okay, my critical reading score, it needs to be improved, my math score. Then I go back and I make some adjustments and maybe I start focusing on those things more. And I keep training and training and seeing how well I do each time. And I take another practice test, see how I do, see where I need to improve. Then I go back and I learn the concepts I didn't do well on. Then I take another test and I keep training and training. It's like if I'm training for a math test, I do many practice problems, see how I do on them, keep going back. If I make mistakes, see where I went wrong. Then I go back, take another set of problems from the book or something, and I keep on doing those problems again and again. And then this can take a long time. And then what happens is, I look at my notes and I keep learning. And then comes the day of testing. So the analogy is, the idea of this is more like the training and testing idea. I just try to give it an example to you guys, like how training and testing works. And the goal is to be able to get right answers, basically. So because it's in supervised, you know the right answer. So in your SATs, you know the right answer for what the answer for the question. What is the right answer? You know the right answer. So don't think of it exactly like SAT problem. Just think of it like the idea that you're studying for a test. And you're taking a lot of weeks, you're looking at your notes and you're doing practice problems and you're seeing how you're doing. And like this is training. So the idea is that for the COVID mask problems, I spent a lot of time labeling people with masks. I mean, or the students did it in that example. They spent a lot of time labeling people with masks, without masks. And then they would keep sampling it along the way. Okay, how is it doing? They would keep trying it out along the way, seeing how it's doing. And if they made mistakes, they'd go back, tweak it using back propagation that Geoff Hinton, I told you that guy, he came up with to help us, that you keep updating it. And then during the testing, you actually, testing is something completely new, something you haven't seen before. Like you guys, this model has not seen all of you guys before, like in this group. So then the testing comes where you actually supply something new and then you see how it does on it. So that's testing. So the idea is like if you're trying out for an exam, and all these approaches use the idea of in supervised learning of training and testing, and there are certain outcomes. So in these cases, it can be classification or regression. And the idea is that if you're studying for an exam, for instance, and you miss some class, you're studying from your friend's notes. If your friend took bad notes, then no matter how hard you study, you're not going to do well, because if your friend forgot a key part and you just study the notes, then you might just miss out on a key part. Like if your friend was sleeping in class and they did not listen to a key part of the lecture, right? Like no matter how hard you study, you won't. So the idea is garbage data in, garbage data out. So when we were training this may not have done as well on Sarah and Nick Curl because maybe it did not see similar examples as that. So that's a key idea in artificial intelligence. So in supervised learning, you have a set of examples and you're training it, and along the way, when you're training it, you test it a little bit along the way. And then you see how it's doing, you keep training it. It could take weeks, months, it really depends on how much data you have. And then you test it on something new and you see how well it did. And that's the whole point, is to apply it on something new. So we like for all these applications. So there's classification, which is sorting items into categories, and then there's regression, which is identifying real values. So which one do you think is the situation for the COVID mask?
Probably classification.
Okay, and why? That's awesome. Why?
Oops, sorry, I got muted. Because in the above example, it like tells you cats are not cats, and in the mask, we train the machine to recognize whether someone was wearing a mask or not wearing the mask.
Yes, awesome.
So like possible, like putting them into categories.
Yes, awesome. That's awesome. So thank you, Sarah. So the way that I see it, if you guys are confused on reinforcement learning and supervised, the way I see it is that in supervised machine learning, thank you, Sarah, that is exactly like, so the mask problem is classification. So there are these two types of problems. And the COVID mask and other things is, I think of supervised machine learning as kind of like machine learning. The way I think of it is like it's parenting and guardian strategies. Like if you had to teach someone something, so think of supervised machine learning as like being helicopter parents, where they're telling you right from wrong. They label everything, and this is something right, that's something wrong. There's nothing, right and wrong, right and wrong. They're supervised. It takes so much effort for them to tell you right from wrong. They're monitoring every single thing in a way, like they're supervising you, like they're constantly checking up on you as well. That's like supervised, right? Like they're labeling everything as right or wrong. And take your school book, this is right, that's wrong. If you do this, you'll be suspended for a few days. If you do that, like all the actions, right and wrong. Unsupervised is that if your parents and guardians or teachers have a hands-off approach, and they're like, if you go out partying till 3 a.m. and then you try to come back and you have a test the next day, if you don't do well, you'll find those patterns. And then reinforcement is if your parents or guardians try another strategy. You do well, you get good points, you'll get like a certain, maybe you want an allowance, or you want to buy this video game or these pair of boots or something. If you do well, you'll get it. Otherwise, you get a punishment. If you're good, you do well in school. If you're a good child, if you're a good citizen, good person, volunteer, do all that, you'll get some reward. So the way I see it for supervised machine learning is it's a one-time prediction. It's either you're wearing the mask or you're not wearing the mask, and you're done. It just needs to predict properly in this one spot. Are you wearing a mask? Are you not wearing a mask? It's like a one-time thing. But when you're driving a car, it's like this: either you're wearing a mask or you're not wearing a mask. There's a right and a wrong answer. Either you're happy, you're sad, you're neutral. It's like either it's right or it's wrong. But for reinforcement learning, it's like it's something that's more ongoing. So if you're driving a car, there's not like a right or wrong per se. It's like something that's mainly ongoing. The action is ongoing. The driving is like something ongoing, and it's really, and along the way there can be some supervised parts, like does the car correctly identify a stop sign? So the machine learning approaches that are out there are all blends of these three. Some can be just supervised only, some unsupervised, some reinforcement, and some can be like a blend of all of them. They can be semi-supervised learning. They can be all sorts of blends. Like your parents or guardians can take a variety of strategies to try to parent or teach you guys. So that's the idea, but these are the three distinct categories, and then sometimes it can be mixed a little bit depending on the application. So there's classification and then there's regression. So sometimes in these supervised, it's either right or it's wrong, and or it's, or it's like there's a certain value, and either you're on the spot or you're not on, or you're far away from it by a few points.